My name is Ishul Abdul Halain. Welcome to my video on the 68K instructions. This is the final part from a 6-part series that will explain the instructions available for programming the 68K microprocessor. Now, let's begin with the binary coded decimal instructions. The functions of the BCD instruction set is to add, subtract, and negate BCD numbers. There are 5 instructions available in this group. We will examine the ABCD, NBCD, and SBCD instruction in the following slides. We are going to have a look at the ABCD instruction. It is short for add binary coded decimal with extend. Let's look at the operation, syntax, operand size, and its effects on the condition code registers flags. The operation is to add the source operand, destination operand, and the extend flag together. The results are stored in the destination operand. Note that the subscript 10 represents that the source and destination operands are holding binary coded decimal numbers, which are essentially base 10 numbers that range from 0 to 9. The syntax to use this instruction is ABCD-DX-DY or ABCD-AY-AX. The allowed operand size is a byte only. Finally, upon execution of the ABCD instruction, the X, Z, and C flags are affected. The N and V flags are inverted from their previous values. Now for an example. Let us assume that D1 contains the long word value of F00100299. D0 contains the long word value of 100111101. The status register's flags at this point is 01000. The instruction to be executed is ABCD D1, D0. According to the operation, the contents of D1, D0, and the value of the X flag will be added together, and the results are stored in D0. Since the default operand size is .b, only the lower bytes of the operands are added along with the X flag's value. Let's add them now. We have 99 plus 1 plus 0, which results in 100. Note that a carry out of the MSB is generated. This will cause the C and X flag to be set to 1. Notice that the operation result is 100, thus, the Z flag is reset to 0, indicating that the addition resulted in a non-zero number. The first 8-bit results of the ABCD operation is moved to the first 8 bits in the destination operand. Thus, 00 is moved to register D0. D0 now contains 1001100. The value of the N and V flags are inverted. Thus, the status register's final values are 10011. That was easy. The next instruction is the SBCD instruction. It is short for subtract binary coded decimal with extend. Let's look at the operation, syntax, operand size, and its effects on the condition code registers flags. The operation is to subtract the source operand and the X flag from the destination operand. The results are stored in the destination operand. The syntax to use this instruction is SBCD-DX-DY or ABCD-AY-AX. The allowed operand size is a byte only. Finally, upon execution of the SBCD instruction, the X, Z, and C flags are affected. The N and V flags are inverted from their previous values. Now for an example. Let us assume that D1 contains the long word value of F00100197. D0 contains the long word value of 0000299. The status register's flags at this point is 01000. The instruction to be executed is SBCD D1, D0. According to the operation, the contents of D1 and the value of the X flag is subtracted from the contents of D0. The result will be stored in D0. Since the default operand size is .b, only the lower bytes of the operands and the X flag value are involved in the SBCD operation. Therefore, we have 99 minus 97 minus 0, which results in 02. Note that we did not require a borrow for our subtraction. Thus, the C and X flag are reset to 0, moreover, the result is a positive non-zero number. Hence the Z flag is reset to 0. The results of the SBCD operation is moved to the first 8 bits in the destination operand. Thus, 02 is moved to the lower byte of register D0. D0 now contains 00000202. The value of the N and V flags are inverted. Thus, the status register's final values is 00010. The final instruction we are going to study is the NBCD instruction. It is short for negate binary coded decimal with extend. Let's look at the operation, syntax, operand size, and its effects on the condition code register's flags. The negate operation is achieved by subtracting the destination operand and the X flag value from 0. The result is stored in the destination operand. The syntax to use this instruction is NBCD followed by an effective address. Similar to all BCD instructions, the allowed operand size is a byte only. Finally, upon execution of the NBCD instruction, the X and C flag are set to 1. The Z flag is affected like normal, while the N and V flags are inverted from their previous values. Now for an example. Let us assume that D0 contains the long word value of 133500011 and that the status register's flags are initially all 0. The instruction to be executed is NBCD D0. The 68K microprocessor will consider the lowest byte of the operand to negate. Negation is done by taking the 10th complement of the operand. This is easy. The 10th complement is calculated by subtracting the operand from 99, then adding a 1 to the result. The 10th complement calculation gives us 89. Now, in order to complete the NBCD instruction, the X flag is subtracted from our partial result. Since X equals 0, our final result is 89. This is a non-zero number, thus the Z flag is reset to 0, the final result is then moved to the lower byte of register D0. D0 now contains 133500089, after execution of the NBCD instruction, the status register is updated to 11011. As a summary, there are 3 points that you should remember with regards to the NBCD instructions. They are all byte-long operations. Thus, the 68K microprocessor will only consider the first 8 lower bits of an operand that is attached to any BCD instruction. The second point you should be aware is BCD arithmetic, such as how the 10th complement is achieved. Finally, you should know how each BCD instruction affects the flags in the status registers. This brings us to the end of our 6-part video series on the 68K instruction set. Thank you for viewing all of them. Hopefully you have gained something. I will see you in future video series. Have a nice day.